Next speaker, I think everyone knows, Jan Kuhlmann. He is from SGS Germany. He is currently the team leader of chromatography, and he's going to be giving us an analytical talk. So this actually begins the analytics portion of the conference. And he'll be talking about analysis of 3-MCPD and glycidyl esters in emulsifiers.
Thank you, Jessica, for this kind introduction. Yes, we start right on. So this is my first presentation at this conference. It should serve as a kind of warming up. It goes for food emulsifier analysis. Now, we see here the ugly twins, 3-MCPD and Glycidyl, that have been addressed already by the previous speakers precisely. They have the sweet little sister called 2-MCPD. And we learned also that they mainly occur as heat-induced foodborne contaminants. And correspondingly, we find them in oils and fats almost exclusively as fatty acid esters. So a few examples displayed at the bottom of the page. Now, what's the issue? We have the toxicological concerns that already have been addressed. So Glycidyl being more problematic as 3-MCPD. And we learned from France that the regulation 2020-1322 is in place for the sum of 3-MCPD and 3-MCPD esters expressed. 3-MCPD, I call it total 3-MCPD, just as a short abbreviation. And GE expressed as Glycidyl in all kinds of vegetable, marine oils and fats and infant and young child nutrition. And we also heard this morning that, or in the afternoon already, that we have further max residue levels in certain compound foods ahead, as well as regulation of these analytes in E471, which is MAG and DAG, mono and diacylglycerides, used as food additives as emulsifiers. And as already addressed by France, there's discussion if the analytes in food emulsifiers really are a concern, because the E471 amounts in foods are very low, let's say 1% or less. It's not so much. Maybe it's different with some margarines. However, this is the results from our lab, just collecting 100 E471 data samples, or samples data therefore, and we see this is recent data from 21-22, and it seems to be that 3-MCPD does not play a major role, but more or less frequently we find the glycidyl esters. But Franz already addressed that if you look to the scaling, this is a surprise. So we are now in the range of up to a few 100 milligram per kilogram. And if we would apply the max level that is set for oils and fats for glycidyl esters, we rarely could identify this line here at the bottom of the scaling. However, we have to accept that this regulation does not apply to emulsifiers. It is food additives, it's not foods. And we have to consider simply if there is possibly an impact of GE coming from emulsifiers when we analyze compound foods. And of course, if we extract foods, we will end up with these emulsifiers in the oil phase. And if we would assume an oil phase containing 1% of emulsifier, and we would elevate these levels accordingly, we see that still a number of samples would exceed these levels. I will point out this later in the presentation, focusing on occurrence of or on the contribution of other sources as RBD oils and fats tomorrow. So now coming to 3-MCPD, this is a different scaling, just to see that MCPD esters do occur in food emulsifiers as well. We have no correlation with the GE contents. This is nothing new, but from case to case, it's also considerable 3-MCPD contents. However, the GE is a more problematic issue with regard to E471. Now, the question is from analytical perspective, data already has been collected, obviously, otherwise EFSA could not have made any decisions, or the European Commission could not have made any proposals. How to analyze at trice level, MCPD esters and Glycidyl esters. So we have more than 10 official methods available. AOCS was very active. Most prevalent and accepted is the so-called indirect methods. Core components are released out of the esterified forms. And I would give you just an example because it is important for understanding the following slides. So we start with the esters, and if we would apply, for example, the alkaline-based B method, you also could go for acidic ester cleavage or enzymic ester cleavage. You release the core components. If you go the alkaline approach, you have undesired side reaction to a small extent, but this is not the issue now. The important thing is the Glycidyl is now in its free form, unstable, very volatile. You can't analyze it directly. So you have to stabilize it. And the most recently applied approach is bromination. We come to the 3-MBPD. So it's a big brother of the 3-MCPD. And this is a smart solution because now we can apply a one-pot derivatization reaction, which is required from technical perspective to make these analytes suitable for GCMS analysis. It's just what you have to do for analysis. And then accordingly, you have this chromatogram with the 3 analytes, and they are detected not as free analytes, but as PBA derivatives, and the Glycidyl is detected as PBA derivative of its transformation product. So it's a two-step chemical interaction in between. And this might have some consequences. First, to address the question, can we analyze food emulsifiers with the official methods? If we look to the scopes, we do not find the emulsifiers, so they are not covered by the official MCPD methods for oils and fats. And the recommendation from an analytical perspective is, whenever you apply an analytical method for a new matrix, really pay attention and check trueness and precision of your method. So in this regard, it makes sense to check if there's already information available. And it was in 2013 when a more or less unknown researcher presented at the AOCS expert panel comparison of the official method applied to emulsifiers. The outcome was satisfying result comparability for 2 and 3-MCPD esters, but inconsistencies with the A method, which gave higher findings with Glycidyl. That was confirmed a few years later by the Joint Research Center. And they found also the A method giving overestimations. This can be minimized by applying SPE as cleanup, but this SPE is not part of the official methods. So it's not officially validated. I have to address that because the A method does not work properly, this does not mean that the other official methods really will work. So there are rumors that labs or testing clients more or less frequently complain on inconsistent results when analyzing emulsifiers. And I would like to go a little bit deeper into that. One point we have to consider is that within the official methods, it's a clear advice if you have solid fats, solid samples, you have to melt them for aliquotation. And this were some results from a set of routine samples that we analyzed for GE contents on a client's behalf. We had no information about the nature of these emulsifiers. We repeated the analysis several times for certain reasons. And you can see with some samples, the GE results are very reproducible, but with other samples, not. Luckily, we had some retail samples available. And when analyzing those ones which have not been molten and remolten and remolten and remolten, we came to higher findings. So this gave us the idea GE might decompose when samples are molten in food emulsifiers. Secondly, we were on the search for a reference material. This is mandatory to check the daily routine applicability of your method. So we took E471 pellets because they were easy to take for aliquotation, and we did not apply sample melting. But we first found high inconsistency of results, high variation, and also over a period of around about 1 year, part by part decomposition of the GE. So we have to state that this decomposition obviously can also take place without sample melting during storage at room temperature. And to make it almost mean, these effects do not occur with all samples, and you can't predict if they occur or not. So conclusions from this is, if an analyte is destroyed during sample preparation, a method is not suitable. And as you cannot predict if this takes place with your emulsifier samples, you should not apply the official methods in the way that they have been validated via sample melting. And even if no melting is applied, you might observe GE decomposition during transport or storage prior to analysis. And this very clearly means, in case of instability of a compound, the analytical results might be precise and correct, but they reflect the analyte contents at the day of analysis, not before and not after. And maybe this GE instabilities in some emulsifiers might explain some of the issues that were addressed previously. However, there's still this artifact formation with the A method. And of course, we intended to check if this also might take place with our B method, which we apply most commonly, and which seems to be a rocket method. But here's two strange findings from two samples we analyzed several years ago. You see, the repeatability of MCPD analysis is almost perfect. For both samples, always the same results. But with GE, it was absolutely unexplainable. It is heat-induced processing contaminants. The contents are not allowed to increase and then decrease later on. And also, if decomposition takes place, like in the second sample on the right-hand side, it starts slowly with the decomposition, then between day 37 and 38, it's a strong decomposition, and then we have an increase of results later on. So we thought that our method application had some errors in between, so we spiked the samples. But we had perfect recoveries, 100%, plus minus 1, 2%. So it was a sad day to me to accept that even with my most beloved B method, we have some inconsistent findings, and this is convincing indication for artifact formation. And so we had to get a little bit deeper into that to have an idea what could be the reason therefore. And in this regard, we have to remember what happens during bromination. We have the attack of the bromide to the epoxide. And this also takes place with a stable isotope labeled internal standard. Now, we have a side reaction, which is formation of 2 MBPD, because we have a cyclic system and the bromide can attack from the other side. And this gives us the Glycidyl as 2 MBPD PBA derivative, and we can detect this component. It has just a much weaker signal, also covered by the internal standard. And mostly the ratio between 3 MBPD and 2 MBPD seems to be more or less stable. Coming to artifacts, if we have components in our sample containing an C3 system with a leaving group X, we could imagine that bromide substitutes the X and gives 3 MBPD artifacts, which gives GE overestimations or false positive findings. And we would expect, as with the previous samples, poor reproducibility because substance with leaving group X has no internal standard which could cover this reaction, which certainly is temperature, time, and pH dependent. This all is covered for the Glycidyl, but it's not covered for the X component. And also we observed that 2 MBPD artifact formation almost not takes place. And this is very much the same with the MCPD formation. Mostly the 3 MCPD is generated directly out of the oils and fats and the chloride. But the 2 MCPD not. The 2 MCPD is generated mainly out of the 3 MCPD esters by isomerization. And so it was also with these strange emulsifier samples that we observed strange 3 MBPD to 2 MBPD ratios, commonly with lesser or no 2 MBPD. So artifact formation, as already mentioned. Our idea to overcome this limitation is to quantify simply the Glycidyl via 2 MCPD. So here's the samples again. When we take the same raw data, so it's not a new measurement, it's just the printout of the data, and now quantify the Glycidyl via 2 MCPD, we come to these findings. And this makes much more sense. So we have much lower contents, we have a decomposition, yes, but it takes place as expected, slowly and over a long period of time to a significant extent, but not with some strange breaks in between. And also remembering our reference component, we thought that the deviation between the single measurements was due to different contents from pellet to pellet possibly. But applying the 2 MCPD quantification, we come to these findings. So this is much better reproducible. And of course, we have this decomposition, but it makes more sense. And to our surprise, with some days, we had a perfect match between 2 MCPD and 3 MCPD quantification. On other days, there was a factor of 2 in between or so. So the Glycidyl quantification via 2 MCPD seems to be much more repeatable, much better repeatable, and also being more realistic. The disadvantage is we have this lower sensitivity. Correspondingly, we modified our method for certain points, no sample melting, but you have to develop an alternative for a block of emulsifier, increased sample weight to compensate sensitivity losses. And very important, always checking the ratio 3 MCPD to 2 MCPD. In case the results for Glycidyl esters match, we take the mean. In case we have a larger deviation, the lower value is taken. And we call this method the SGS 3-in-1E method, by the way. Of course, this was an in-house approach, and we need to check this by a kind of method validation. And therefore, you need a MLT, a multi-laboratory trial. You need a method which was available, but you need also suitable testing materials. You need a sufficient number of participating labs. You need a study director. He has to be very, very much long-suffering. And in this regard, it was a lucky coincidence that a FEMA contacted us to have a joint venture in order to develop or validate a so-called emulsifier method. So, and around about 1 year later, after all the non-compliant agreements were signed, we received 40 samples of food emulsifiers covering all subclasses of 471, also 475 and 6. And these samples were analyzed several times. And then out of this set, we picked 10 to take for the MLT to cover as many subclasses as possible, to include blank materials as well in order to see if this artifact formation might take place with other laboratories. And we also took certain combinations of analytes, high GE, low 3 MCPD, and vice versa, in order to control these undesired side reactions which might occur with the alkaline ester cleavage. So the practical conducting was the way that we shipped the test materials under dry ice cooling, of course. We took 10 materials as blind duplicates in order to make it difficult to the participants to identify the duplicates. And this now is the weak point of the study. It was just 6 participating labs as FEMA decided to have this ring trial not open to external participants. But you need at least 8 data sets for statistic evaluation. And therefore, the German lab supplied 3 independent data sets, which seems to be a curiosity, but it's acceptable according to ISO standard for method validation. And now the statistics were done also according to ISO, so struggler and outlier identification elimination according to Cochran's and Grubbs. And then we decided to say the method applicability is confirmed if reproducibility was not exceeding 30%. And also we had 7 valid data sets a minimum with Horrod ratios in the acceptable range, or if just 6 valid data sets were available, the normal Horrod range, which is more narrow, has to be given. Finally, in 2020, the study results were circulated to the participants, and here's the summary. So in principle, I could have given this presentation in just half a minute to show this slide here. You see the 3 analytes and the analyte levels tested in the MLT being or showing acceptable reproducibility. So of course you can analyze also higher contents, but you should not go for lower contents. However, the method applicability seems to be relatively low, 20 ppb and 70 for the MCPD esters, and understandably higher for the Glycidyl esters. So this is good news, or this was good news. And all the results and also the study outcome has been published in 2021. And so this was my phase when we finalized this project. I have presented this already at AOCS annual conference 2 months ago, but what I did not present is proof of trueness, because this was not part of method validation. We did not include spiked samples because we learned from our internal investigations that spiking revealed perfect recoveries without giving meaningful results. So the alternative would be either to apply the new method to other matrices with non-analyte contents, or to apply alternative methods to the ring test samples. And we did both. So this is just a rush through method comparison when we applied the E method in parallel with the original B method to all blends and infant formulae to see if the mean values are matching on if the repeatability is sufficient. Same we did for a larger variety of diverse oils and fats. Of course, there was no differences in MCPD results because MCPD analysis is not changed with the emulsifier method. It goes for the GE, and here we see a nice comparability, but the important point is you might assume that with the Glycidyl esters in emulsifiers, we always had these very much lower levels applying the new approach. Is there a risk of GE underestimation when applying these methods to oils and fats? But it is not, as the results were matching nicely. Just for the last few slides, application of alternative methods to the ring test samples. We had 2 approaches. One came from the European Reference Laboratory for Processing Contaminants, the DTU. They use an in-house emulsifier method based on SPE and acidic ester cleavage, if I'm right informed. And we also applied an enzymatic method, which was a modification of the AOCS CD29DE19. And here's the result comparison for the MCPD. You see the gray bars is the mean values from the Robin round. You see the green values is those that we have achieved with the enzymatic approach, which has the advantage to be not harsh, to be not based on chemical interaction with the molecules in terms of ester cleavage. So it's a very smooth ester cleavage. And we do not see the results from the DTU because they will present those results in their presentation, and it would be redundant to show them here. So we can be still curious to see how method comparison turns out when applying this acidic-based method. So this was MCPD with showing sufficient result comparability, especially also for the low levels that were included in this ring trial. Going for the Glycidyl esters, this is the high amounts in comparison analyzed by the 2 methods, and we match here. And expanding the scaling, it also applies to the very low concentration with 1 observation shown here. This has to be clarified, but I assume no method will really be perfect forever. So in general, we are very much satisfied with these results. And this is a kind of one-up as already addressed. I think emulsifiers will play another role in the following presentations, targeting method reliability and also occurrence of Glycidyl esters and MCPD esters in processed foods as you purchase them on the market. The take-home messages. The previous official methods for analysis of MCPD, E, and GE are not adopted for food emulsifiers and might give wrong results for GE, wrong positive due to artifact formation, or wrong negative due to decomposition by sample melting. This decomposition of GE also might take place during storage and transport, and you have to consider this if you doubt the results of your lab of choice. Finally, this was the core point here, a modified version of the B method for analysis of MCPD esters and Glycidyl esters in E471, 5, and 6 food emulsifiers was successfully validated in an international ring trial. Trueness was checked by cross-analysis taking different matrices and different methods. And this now is time to address a warning. This new method does not automatically helps to overcome analytical issues that are related to other difficult matrices, such as MCT oils, but also fish oils. And the fish oils will be part of the presentation tomorrow. No, in the afternoon, in the late afternoon. So in the end, we see everything comes together. So the emulsifiers and the method reliability is connected stronger as you might think. Now, this is the latest slide, and you see how much time has passed during performance of this ring trial. It's not an easy story. It's not a short story. It takes ages. Thank you for your kind attention.